I see it says Samantha. It's fine. If you can't change it right now, I actually do recall you are Samantha. Team color and name.
Oh, green car.
Cool. Okay, so as you can see, I'm trying to answer multiple questions at the same time. Going to Canvas now to try to confirm what sections are going to be on the exam. Now, when you ask such a question, I want you to know that I don't know it, but I'm going to deduce it from the same information that you have. Meaning,
I think it's from like 11 to 15 modules.
all I have to do is do this, exam 2, module 11. Does that make sense? So module 11 on.
Is that what the test's going to be on?
Yes.
All right.
Module 11 on, meaning I don't know what we're going to do tomorrow. It's because I thought 12 and 13 were all of yesterday, but 13 might be part of today and part of tomorrow. So I don't know if there will be a module 14 on Thursday. Okay. But as far as we can tell, for sure, 11, 12, 13.
Okay. Sounds good. That's all I needed. So thank you.
Sure. And anyone else have a question? Of course, read the screen while I talk to other people. Anyone else have a particular question? This is just for those who have missed today's independent study.
Home portion.
Maybe I should.
So the module 13 homework or worksheet is due tonight, correct? And then what about the homework? Because there's not really anywhere to turn it in.
Okay, so here's the textbook. I guess here's an example. I'll watch the video below from the 2-hour, 30-minute mark to 2:55. So watch a 20-minute video. That should take me to YouTube. Okay, I'll click on it in a second. Watch it from 3. That's about a 37-minute video.
An independent
Practice.
study, I thought we didn't have to turn it in.
Okay. This we did yesterday though, didn't we? Or is that? Oh no, yeah, we did interpreting. Got it. Okay. We have this. We have the key to this, which obviously if you have the key to it, it's not something that's going to be collected. Do you get that? Right? I mean, the chances of putting out a key but collecting it is silly because students could just copy the key and turn it in. So I'm assuming that because there's a key here and a key here, that you have to do it, but I don't think it's going to get collected.
I think only you have access to that. That's not
Yeah,
allowed.
we'll have the key.
Yeah.
Oh, you guys don't have the key?
We don't have a key, no.
Oh, okay. Okay, so then you do have to do it, and I have a key. And so how do you turn it in? So there's no submit button here for you? So obviously for me, there's never a submit button unless I switch over.
She's talking about the homework, like where it says, like the textbook homework part. Because that one doesn't have a due date. So she's wondering.
Are you talking about like this?
Yes. Is that supposed to be due tonight or?
But they told us because it doesn't have a due date that we don't turn it in.
Okay, that's what the tutors at the time told you during independent study. Okay.
I mean, because there's no way to.
Okay. See, I should read my messages earlier than sooner. I mean, than later, sooner than later. Module 13 due tomorrow, but should not be finished. Oh, but should be finished tonight. Yeah, that makes sense though. If you try to do that homework tonight, tomorrow's lecture will make a whole lot more sense to you also. You get what I'm saying? So it's not due till tomorrow. And unfortunately, the way you guys hear that is, oh, I don't have to do it till tomorrow. But it's recommended you finish it tonight, but it's not due till tomorrow. Okay, straight from our pronto messages between us tutors and instructors. Questions so far? Like, we're gonna jump into the questions here, but any other, like, administrative questions? No? Okay, then let's get to this. Downloading. Okay, showing my taxes. Don't do that. Give me a second. Closing my bank accounts. TurboTax. Okay, we're good. Okay, so how many with the visually, or visually besides Samantha, she could tell me verbally, how many of you have read the textbook for Module 13?
Kind of.
Jade kind of read it. Destiny, yes,
Kind
no? Kind of.
yeah.
Kind of. Through it.
Yeah.
Samantha?
Yeah.
Yeah. Mary?
Yeah, I read it.
Okay. Anyone else? Oh, did Jackson leave already?
Yeah.
Oh, shit. Okay. All right. So, Joshua, take the time to read that.
Wait, I have a question. So the stuff we did in class, like what we're doing right now, is that kind of similar to the
Take time to what?
To read Module 13 textbook.
Oh, I read it already. I just didn't get the formulas and how to work it.
Okay. Okay. So everyone's read. Question. I was getting a question. Who was speaking?
Jade?
Go ahead, Jay. You were saying?
Like what we're doing right now is kind of like the same thing as the practice thing we did in independent study, right? Kind of, sort of.
What we're doing right now, as in like right now, or what do you mean? What we're doing right now on Canvas in terms of Module 13?
Yeah, Module 13, like how you're going over.
Yeah.
Okay.
Yeah. So whatever you did today in class is pretty much. I mean, I don't want to make you do it twice, but to be honest, I mean that's exactly what we have to do to grasp what's going on, right? So to read the book twice, to answer the homework questions twice, to do this helps us. So that's what I'm about to do now. And if you feel you don't need it, obviously you might leave. But I hope I always give a little more thorough explanation than the book and your professors.
Because I was having trouble with independent study, so that's why I wanted to make sure.
Okay, cool. Oh, good. So then, yeah, we'll go over that. I think everyone would like to go over these questions. Okay, so let me have them both open. I won't read them, obviously, because it takes time to read a textbook, right? But I would like to have it open so I can reference and point to, hey, if you don't get what we're doing, go look at that section and reread that a couple times. Module 12. Oh, I never downloaded Module 13. Okay. So how can I shrink this? Okay. Okay. So module 13, what's it about? Confidence intervals. I'll go over what the main idea is with the confidence interval. Basically this same diagram. Often will repeat myself. When you have a lot of data, individual values, what ends up happening is this population would be distributed a certain way. It could be normally distributed, it might not be normally distributed. It might be skewed. The idea for sampling is, the population is walking around in the oceans, the malls, campuses, the state of California. They're just moving about. Well, we picture them as like moving objects because we want to study people, but technically they could also be very static. They could just be a bunch of numbers and names and records on a worksheet. But the idea is you don't have access to all of it. You have access to some of it, and you can come in with the idea of sampling. And the sampling might be random, like that group inside the orange creates a statistic. So by sampling, you create a statistic. The type of statistics that you can create are going to be p-hats or x-bars or s's for standard deviations. But the blue population itself has its own p, its own mu, and its own sigma. These are parameters. That makes sense so far? Like the entire blue population has its proportion, its mean, and its standard deviation. But by randomly collecting samples, the samples themselves will have proportions, means, and standard deviations. The idea is if you collect enough statistics, right, which will be values that I'm just going to signify by orange circle, they start to accumulate. And when they do accumulate though, when your sample size was more than one, it's almost, well, yeah, it's almost always the case, almost always. And when I say almost depends on the central limit theorem. If you check off the central limit theorem, which has 3 conditions, 1, 2, and 3, and you check that off, then almost, not almost, now for sure it's guaranteed that the distribution is going to be more narrow and approximately normal. Okay, does that make sense? And the idea is that the orange values start to cluster around the parameter. So this parameter is unknown because you don't have time to look at this distribution from here to here, but it is going to be centered. It turns out that they start to cluster around this. A confidence interval is saying what happens if I were to only collect one of these samples, just one, right? See how that one fell here? If I were to create a window or an interval based off that with the upper and lower, lower and upper values, will the blue unknown parameter be in this interval? Does that make sense? A confidence interval is collecting one sample, determining to what measure of certainty do you want to estimate an interval that captures or contains the population parameter that we don't know. Is that making sense? I mean, yes, no? I got Joshua frozen and then Samantha and Jade with no image. The only person I can see is Catherine.
That helped me for sure.
Jade, yes, no?
Kinda, sorta.
Sorta.
Okay, the kind of sort of. So we have two kind of sort of, and that's okay. Like, so like, it's like, it's my responsibility to be able to make the connection. So, around which parts do you not get? You know, is it the purple concept that we've been studying since week 1 and week 2, or is it the blue concept that we started studying around week 2 and 3?
I would say orange. For
Who
me.
said?
Yeah, the newer
Jade.
stuff.
Okay.
Yeah, the
Newer
orange.
stuff.
No, that's good. That's good where it's happening. So the central limit theorem and this whole clustering, right? So do you see how the purple dots are individual people, right? So like you could just say, let's say those were human beings with heights, and the purple line now is feet. Every purple dot has a certain height, and then we figure out where they land. And you know, sorry, when you start to find a lot of people of the same height, like 5'6", 5'7", 5'8", 5'9", common heights, right? That's where the mound starts to grow. The data starts to accumulate there in terms of frequency. And you have very few, let me get my highlighter so you can see my mouse. You know, you have very few 4 feet tall people and very few 6 feet tall people. But those things being numbers, each purple dot being a person, but it's also attached to a number. You can get this, you can describe those numbers with 2 phrases: mean or center position, and spread, which is standard deviation. So from those numbers, you can get like this value that we like hold up and like adore, right? Like, oh my God, look, I found this number called the average for this group of information. And then we use that number as if it's so important. So from a math point of view, that's how it's revered, right? Like the average value for all these values. And then you're probably wondering, why is that significant, or why is that important? Why am I taking this class, right? Well, that class, that value, if you can find it, describes a population. It says something, because once you have this center value, it's a fixed point that you can reference and make a lot of statements from. For example, if you find that value, I can now tell you, Joshua, are you taller or shorter than this value? Jade, are you taller or shorter or above average or not above average, right? Then we get this other value called spread. The standard deviation will measure the variety in things, right? And so you're probably wondering why I'm talking about the blue and the purple instead of the orange, because you have to make that connection. It's a transition in terms of the information. So I'm sorry for taking long, but I'm getting to it, okay? So now you have standard deviation. It measures the variety of people. Like it's important to know that, because, I mean, you want to know, you know, is there a certain type of people voting for certain political candidates, right? Like, is it certain ethnicities? Is it certain cultures, right? Are certain people scoring high or scoring low on exams? Are certain people being like cheated out of what they need to get? There's been studies where, like, you know, people of minorities like get bad bank loans, right? Well, if you take the whole population of loans and then you can figure out that, oh, there's an association or correlation between having low income or a certain ethnicity and then like the highest interest rate, then you can make that association with statistics, right? So these are the values of understanding how to study things, because you can now say, if you're, because like you could get a high interest loan, but that just could be your bad luck or your bad credit score. But if it's like 2 standard deviations away, now we're going to say, well, that's unusual that you're getting that. You get what I'm saying? So that's why we want the center, so we understand for above, below. Then the standard deviation tells you if there's variety amongst a group or no variety. And then you could even break up the data. You could just literally like go into StatCrunch and by category break it up. And so say like maybe 18 to 25-year-olds are getting really bad interest rates for their credit cards, or really high rates for their insurance. And then 25 to 30-year-olds are getting better things. And then you can see if there's more variety or less variety in the groups. So do you see why these numbers are important? Okay. So that's called descriptive statistics. Okay. Descriptive statistics is you just get those numbers and you calculate them, and that's it. Okay. Hey, Joshua, you're dozing off on me. It's okay, but grab some water, stand up, open the window, anything. Okay. So what's the goal now? If you had the time to do that, you would do it for the whole purple population and you get that magical blue number. The problem is you can't get that blue number unless you talk to all the purple dots. So here comes the central limit theorem, okay? It says, if you satisfy these 3 conditions in the way you collect information, then we can promise you that the information starts to cluster in the orange fashion. The big idea is we know a lot of information about the normal distribution, right? It's kind of like saying, if we found a new animal out in the wild, but it had like fur and it didn't lay eggs and it breathed oxygen, right? Like now I'm like, man, you give me those 3 conditions and I might create my own theorem called the mammal theorem, right? You found a new animal with 3 check marks that make it so that it's practically a mammal. Once I know it's a mammal, I can tell you a lot more stuff because we've been studying mammals all our lives, right? So the normal distribution is a very special type of distribution. So we want to know if things like cluster or shape or fall into a normal distribution, because once they do, then we have calculators and we have math to tell you probabilities of something happening, something not happening, right? So what we're saying is, if you have the purple population, and if you were to collect randomly from that purple population, that's condition 1. If you were to collect large samples, of course, right now, just so you know, we have 2 central limit theorems, right? We have one for proportions, one for means. But both number 2s are very, very similar. They're saying, don't collect small samples, collect enough samples, right? And then the 3rd condition is if the population is large enough, right? Once you have that, we're saying that the collections of samples, so 10 purple dots, or, I should say 50 or 100, because again, we need, so right now I'm doing a very general thing, but then I messed up when I got to get into the specifics. NP greater than 10, NQ greater than 10 for P hats. For mu's, we have N must be greater than 25, or the population, right? When I mean population, I mean the purple dots, is normal. Okay, so that's the specifics. So let me get back to the general. if your samples are large enough, where you satisfy this or that, check. And 3, the purple is always 10 times bigger than the size of your orange sample, right? Then the central limit theorem promises you that collecting in groups and these size groups create a statistic where you create one sample and another sample and another sample, and they start to fall in this distribution, right? So we did that with 2 examples. We did that with the Gettysburg Address, and we did that with the senators, okay? For the Gettysburg Address, for example, we also taught about bias. Now, you can forget about bias, kinda, meaning we taught you how to do it incorrectly, and then we taught you how to do it correctly in the same example, right? So the Gettysburg Address is when you collected your first 10 words, each one of you collected words, but they were biased, right? Your average came out wrong. Your averages came out like 6, 7, or 8 words, average length, letters per word, right? So when I say this, I know I'm talking and it gets boring, but does it really connect? Like if you didn't do that assignment, or that assignment doesn't make sense to you, what I'm saying now for sure won't make sense, right? So I just need like a nod, like, yeah, I do recall getting the words from the Gettysburg and kind of understanding the main idea, right? And so those words were collected wrong. That's why we call that a bias. So in other words, that version of collecting breaks rule number 1 for the CLT. CLT rule number 1 says you better collect randomly. Don't give preference to anybody or specialize or prioritize anyone, right? Okay. Hold that information, put that aside. Side story. If I wanted to know what percentage of females or males are in college, do you agree I shouldn't sample from a women's studies group, right? If I want to know what percentage of college students are male, I shouldn't sample from a women's studies class. That's a biased sampling. I'm going to collect like 80 people in the class and there might be like 5 to 10 males. You get what I'm saying? So that would be breaking rule number 1. So that's just one example. Okay, let's come back to the central limit theorem. So when you collected those words in the Gettysburg, don't break rule number 1, collect randomly. So we fixed that. Later down in that assignment at the bottom, we showed you how collecting randomly 1 through 268 was a good way to do it. And it got you a better average, right? And then you did it more than once though. That's the cool part. I think you did it, what was it? 5 times? Yeah, I'm trying to remember. You did it 5 times, and each of those 5 times, the numbers were a little different, but together they were closer to each other. That's the start of the purple happening before your eyes, right? And then the average of the averages, I think we got that. Can't remember if we did, but the average of the averages is basically going to be very close to the turquoise, the blue question mark. Now, the cool part is someone did go through all the purple dots in that page, because there was only 268 words in the whole paragraph, and someone did do it, and they got an average of 4.8 or 4.29, something like that, right? And then you saw that your well-collected random samples of 5 words repeatedly were closer to this average, even though you never went to look at it yourself, right? Okay, so now I'm going to go through that whole story again for the senators, right? So just, for the Getty's one, that was for the means. So that was, Getty was this. Okay, so I'm gonna keep that green. So Getty was green. Then, let's see, what other colors do I have? This was senators. So for the senators, there's 100 senators. That's not a lot or a little. That's relative. Up to you if you wanted to say that's too much for me to go look at or not. But our population was 100. And our goal was to find out the percentage of the 100 senators that were Democrat. Let's assume that 100 is too much. It's too big of a population. So what are we going to do? We're going to repeat the whole Gettysburg process, or the central limit theorem. We're going to try and do the three things. Okay. Now, the central limit theorem wasn't brought in for those two, simply because the sample size is not large enough. So we can't actually, like when we took the senators, we took a sample size of 10. That's actually not large enough to satisfy CLT condition 2. You get what I'm saying? I'm going to repeat that in another way. The senator and Getty's thing is trying to teach about the central limit theorem, but we don't mention, the teachers, instructors don't mention the central limit theorem yet in those activities, because those activities are halfway there. They're not, when we sampled 5. That's not big enough of a sample. When we sampled the senator, we sampled 10. That's not big enough of a sample. So we can only do it like in a small way so that you don't take 3 hours calculating something. You get what I mean? We have to like create these small worlds where you collect small samples. Okay. But both of them are trying to lead you into the central limit theorem. Okay. So when we did the senators, we collected size sample 10. We did do it randomly, so we checked off number 1. Did we collect large enough? No, but that's okay because we're just trying to teach you what might happen. Okay, so you collected the 10 and you got 4, sorry, yeah, I don't know how to do this. You got 4 out of 10 Democrats and then 5 out of 10, and it varied. But when you did it 100 times, did it not cluster like this, right? It clustered very similarly to this normal distribution, okay? And they eventually landed they started to center themselves around this. So when you talk to 3 people, when I talk to Destiny and I talk to Jade and I talk to Joshua and I got your values, Destiny might have gotten 46%, Joshua maybe 49, maybe Jade 50, maybe I got 47. But all of us are experiencing this interesting phenomena, right? Like I didn't work next to Jade. She did her own thing, but her cluster came out like my cluster. And I predicted 46 and she predicted 48 or something, right? And we're like, wow, like that's starting to tell us something. So if I looked at my information and her information, we get a mean proportion, and that proportion, if we estimate it, like if I look at those two, like at least I now know it's probably, between 46 and 48, right? And then if we have the luxury to go check the real thing, which someone did for us again, actually no, we did it ourselves that time because there was only 100. We found 47 Democrats, right? So like my sampling kind of pointed out to 47, but it missed it. Jade's 48% kind of was trying to point to that 47, but it missed it. But both of us keep landing very close to it, right? So that's what the orange is about. How to sample randomly, how to sample enough, and is our sample related to our population size? If you do it correctly, you're going to get this distribution. And the reason that's important, it's very important, is you can then predict someone else going to find that themselves. Let me say that again. Once we know the theory behind the idea that the orange cluster is going to create a curve, right? I can now ask my sister, who's not taking this stat class, right? And ask her, go randomly pick 10 senators. And then I can predict the probability that she gets 40% or more. You get that? like one, because I've seen it work for me, for Jade, for Joshua, for everyone in this class. I can now make bets about what kinds of samples my sister will be able to find. Right? She has nothing to do with the stat class, doesn't know anything about the stat class, but I can start to bet money on the probability of her randomly picking 10 senators and finding 7 or more, right? So let me talk about that. Let me show that on the screen. Okay, so my groups. I'm going to the senators. I'm going to do 200 samples instead. The key is really here, though. This is a problem. I should be sampling more than 10, just so you know, for the central limit theorem. But remember, this activity was before the central limit theorem. But right now, all I'm trying to get for us is I want a center, an orange center, and an orange standard deviation, which we don't call the standard deviation anymore. We call it the standard error. Okay. I want to get those two things now, so I can literally tell you what I predict for my sister or anyone. I mean to say anyone unrelated to the class. What's the likelihood that they hunt down 10 people? 10 senators to be precise. What's the likelihood that they hunt down 10 senators and find 8 Democrats or more, or 9 Democrats or more, or less than 5 Democrats? Any question you want, I can now answer. Okay, and I'm willing to bet money on it. Okay, so I'm trying to find the center of our distribution by first collecting samples of 200 times. Oh man, I don't have that one wording. Sorry. Take. You see how I'm titling it 200 samples / orange statistics? I'm about to pull 200 p hats right now. There are my 200 p hats. Let's look at the distribution. Right, normally shaped, right? 0.4765. What's the true population proportion? 47. You went counted 100 senators. You counted exactly 47. I mean, I'll even show this, right? What do I do? Sort here by ascending. Come down here. There it is. The last Democrat, 47. Right? And so, okay, cool. I have a mean. So 0.4765. Now this is through experiments. The theoretical one would be 47, right? But how do we get to the theoretical? Law of large numbers, right? You saw I got a more accurate. I mean, you guys did 100. I did 200, right? Watch. Let's do that again. Data. Sorry, sample. Affiliation. What am I changing? Yeah. 10. And then I'm going to do 500. 500 statistics orange p hats. Okay, I do a different histogram on the 500 with the mean. Okay, so what's the mean here? Oh, 48. Dang. Okay, I was hoping it becomes even more accurate, but that's the problem with simulations and randomness, right? One other way to get the average closer is to repeat the experiment more times for law of large numbers. It didn't work that time. The alternative is to instead of take samples of 10, take samples of 20, right? But look at, I'm struggling now for the third condition in the central limit theorem. Do you see what I'm saying right now? If one way to get a better prediction is instead of looking at 10 senators, why don't we look at 20 senators, a bigger sample? That should be more accurate, right? Because you're looking at more data points. Everybody understand that? Sample size will increase accuracy, right? So, but I'm telling you that puts me at odds. That creates a new problem for me because then I can't do condition. Oh, I can't do condition 3, right? Now I know I write it like that. Remember, I haven't gotten into the specifics, but the population better be 10 times the sample size. So if I go with 20 senators, unfortunately, I don't have 200 senators, right? So I can't collect too large of a sample before I start to conflict with condition 3 of the central limit theorem, right? So I need to have more senators if I want to collect larger samples. But again, remember, this is all before the central limit theorem, so I don't really have to follow the rules now. Do you get what I mean? We're like, it's a weird transitionary period we're in right now in terms of the learning and the strict rules and like building the idea, okay? So I'll still do it though, since we're already breaking the rule of taking by 10. We might as well try to see what happens when we sample 20. Affiliation, sample sizes of 20, 200, back to 200. And 200 orange statistics of sample size 20 though. So that creates a whole different column, which I hope to see how we can compare. I believe that's good. Oh, it won't show it to me. I'm pretty sure that's the one. There we go. 0.474. Okay, so this was 200 of size 10. This is 200 of size 20 samples. This is 500 statistics of size 10. Obviously, I could do another one of 20, but so I don't spend more time. I think you're getting the idea. Depending on how long you run the samples for, in terms of law of large numbers, you may or may not get more accuracy, but you should. Depending on the sample size, you definitely should get more accuracy. And the interval should decrease. So look at the range here from 1 to 0.8. And here it's from 0.25 up to 0.85. So it didn't shrink as much, but it should have. Let me explain what I'm trying to say. Side note, now I'm getting to the specifics. The standard error for the p hat distribution. Standard error formula is p q over n. All I'm saying is that when this starts to increase, it starts to divide this number and make it smaller. So as n increases, standard error decreases. It shrinks. Yeah. Okay, so that standard error is, remember, spread. And I hope you know that spread means variety. If you collect sizes, sample size 20, the p-hats will have less variety amongst them. And less variety amongst them creates a more narrow distribution. So that might be size 10, that might be size 20, this might be size 30 samples. As you start to increase the sample size, the variety and spread starts to narrow. Okay, I'm going to try and demonstrate that here again. I'm going to take sample sizes of 30. Number of samples, 200. Bless you, Samantha. I think you were sneezing even though we can't hear you. Okay. So histogram. I should have titled that one 200 samples of size 30. Put the mean on there. Okay. Okay. I'm happy because I'm breaking some rules of the central limit theorem, but some of the predictions are coming true. Some of them. Look at the spread here from 0.1 to 0.8, from 0.25 up until 0.85, right? But we only got one of those, so give me a chance to say, just delete that one and just say it went from 0.25 to 0.8. That was actually a shrink in the range, right? And then look, when I took samples of 30, it went from 0.25 up to 0.7. It's starting to get more accurate. Each one of those samples tends to now I don't want to say be more accurate. Each one of those, by collecting larger samples, repeated number of times, the way they cluster are more accurate to the unknown population proportion, right? So let's look at the mean here. 4.7, 4.74, 4.70. You guys get that? Like I'm happy that I'm giving you the time that we don't have in lecture to demonstrate it for you. Do you get that? 4.70. It got more accurate. You know the real one's 4.7, right? And that's because I collected in 30s, right? Okay, so I'm going to now answer the question, okay? I need the mean and standard deviation of this, the mean and standard deviation of this, and the mean and standard deviation of this, okay? So I hope you guys know how to get that. That's in calculator. Sorry, statistics, summary stats, columns, and then pick each one of these. And I want the sample size, the mean, and the standard deviation. Okay. So okay. 0.475 and standard deviation is 0.157. Mean is 0.474. Standard deviation is 0.103. And the mean is 0.470. 2, and the standard deviation is 0.078. Okay. So clearly the standard deviation, the spread shrunk as I took larger sample size, 10, I wrote that down, and it was 10, and it was 20, and it was 30. Okay, so to answer my question in terms of my sister going out to take samples of senators while she's on her trip as a news correspondent. I'm making up a story. If I go to stat and I go to calculators and I go to normal, I can use these numbers here, right? I can use these numbers here to make a prediction, or to at least an informed bet in some sort, right? So if my sister were to say, I'm going to it has to be the 115th Senate, so now she has a time machine, okay? She goes back in time, it's saying, I'm going to randomly talk to 10 senators. I bet you that 9 out of 10 are going to be Democrat, right? We can't get the probability that she finds exactly 9 out of 10. Actually, we can, but don't worry about that. It's going to be phrased more as 9 out of 10 or more, right? So 9 out of 10 means in the scenario that where she's taking 10, then 9 out of 10 or more would be 0.90 or more, right? I want you to really understand this story. The chances that she talks to 10 senators and that she actually gets 9 Democrats or 10 Democrats, the chances that that happens for her in real life is 0.003 chance. You get that? Like, I can predict what's going to happen to her. And I shouldn't say predict. I can measure the likelihood of something happening to her, even though she hasn't carried it out yet. That's why it's important to see how the population gets collected into samples, gets studied again and identified as a normal distribution, and then allows me to make informed decisions about whether something is likely to happen or not likely to happen. Is that making sense so far? Okay, so if my sister says, I'm gonna find 9 out of 10 when I come back after talking to 10 people, and I come back and I tell you I found 9, I'm gonna say, bullshit, right? Like, less than 1% chance that happened. I don't believe you. Okay, it's important that you just, I mean, it's important that you understand everything I'm saying, but what I just said there ties into next week's and the last concept you have to learn for the class. Okay? Whether the likelihood of finding something is evidence to support or not support something. Now, I don't want to confuse you. So right now, let me get back to confidence intervals and testing. Okay. How can we use this shape now? Because we can do two things with it. Literally what I just said about calling BS on someone's evidence finding ability, or she could say the other thing though. She could call BS on my model, my theory, right? If she actually finds 9 out of 10 Democrats in her sample of 10, not once, but twice, right? One alone, if she does find it, it could have happened, but it's so unlikely that it could have happened that she should really challenge my belief and say, you know what? Maybe there's more Democrats in the Senate than you think. You guys get that? It's a two-way battle here, right? Like, she can find 9 out of 10, but I think it's so rare it should never happen. It's a 0% chance it happens. She goes, does it. If it actually does happen, she actually brings me like the 10 random senators, and I see them for myself. Evidence, real evidence. I say, wow, you found a needle in a haystack of a sample size 10, right? Like, you found one of the rare 10 samples that would have 9 Democrats in it, right? You actually did find it. It's so rare that you found it. Maybe she has enough reason to call BS on me. She could tell me, on the other hand, hey, do you think that the 115th Senate is 47% Democrat? Maybe it's a little higher, right? Do you get what I'm saying? So it could be I go look at the list, and maybe my list was wrong, or maybe my list wasn't updated, or maybe her demographic changed, right? So she can say, like, maybe the proportion of Democrats is higher. That's why I was able to find so many in my sample of 10. So that idea, that's what you're going to have to learn next week. But it's very related to what we're doing this week, which is, okay, if we know it's rare to find these odd samples, we know they're all close to the queen fish, right? Everybody, I hope everybody, raise your, right now, let me know if you don't know what I'm talking about when I say the queen fish story. Everyone at least heard it at some point in tutoring or lectures? Okay. What we mean to say is, these orange are the regular fish. This blue question mark is the queen fish. And we know that the samples don't tend to stray far away from this conceptual queen fish, the parameter. All statistics don't tend to be far away from the parameter. Knowing that lets you know that if I catch one of these fishes, I can create a confidence interval. That's what this week's about, confidence intervals. Understanding what they are, but also creating them. Okay? So let me give you an example. Let's create one random sample right now for myself. Random numbers, 1 through 10. Sample size, oh, that's just, try 100. Compute. Oh, what did I do? Oh, yeah, because this has to be 100. Sample size, I flipped the two ideas. Okay. Here are the senators we're going to do right now as an experiment. I'm going to create a confidence interval from my sample. So this is one fish, meaning one sample. So when I say a fish, think a sample, not literally one fish. A statistic, basically. I have 10 things, and I'm going to get some statistic out of these 10 right now in a few seconds, okay? And then I'm going to create a confidence interval based off of it. And then I'm going to tell you how confident I feel that I got the true population proportion, right? So I'm going to take my 10. Dang, I got a lot of windows going on. Let me see if I can do it over here. And I know the message is writing, but one of the rare times I do not want to erase it. It's important that we see the relation amongst all of those. Okay, paste. Where is it? Sorry. Okay. No. R. Sorry, I won't do that. I forgot I could tell this to sample with the letters and tell me the value. Or not tell me the value. So I'm going to sample affiliation 10, just one sample. This is the difference. Before I used to hit compute and it gives me the number. I don't want it to compute. I want it to show my eyes literally the values. There they are. Okay. So I don't know which numbers it ended up taking, but I got 1, 2, 3, 4. So I got 0.4. Right? I just created my first sample fish. I caught my first fish, one of my random fish, right? I gotta believe that this isn't far away from the queen fish, the 47. Now remember, you don't know the 47, but it's important to know the theory behind it. We know it's 47, but imagine I didn't know that at all. I'm like, I got 40. This can't be far away from the thing, but how confident do I want to be and how wide of a window do I want to make my interval? You see what a confidence interval is? Okay, so we have ranges from 1% to 100% confidence. Typically, we're going to want to be between 90 and 100% confident. That's more of a standard convention amongst mathematicians and statisticians. Okay. What I mean to say is, you could have any confidence level. The reason you don't go with the 100 is because it's useless information. Ready? Hey, Mary, I'm 100% sure that there's between 0% and 100% Democrats in the Senate. And you're gonna reply, well, duh, right? Obviously, it's got to be no Democrats, all Republicans, or there's got to be a mixture. Don't tell me it's between 0 and 100%. Tell me it's between 30 and 50, or 35 and 45, or 40 and 80, right? So I'm like, okay, fine. I won't be 100% confident and give you a ridiculous interval. But let me make myself maybe 90% confident, right? To do that, the formula looks like this, which you don't even, I want you to understand the beauty of StatCrunch. In other stat classes, you would have to memorize this formula and execute it by hand. In this class, you only need to understand it, okay? It's p hat plus p, sorry, I'm questioning some things right now. It could be p hat and q hat or p or q. Don't worry, again, for now. Okay, so that would be the formula, and this z obviously is a z-score, and that z-score comes from the standardized normal distribution. So you guys have, I hope you realize the key phrase I just said. There's a standard normal curve, and then there are just normal curves. If we go back to the z-scores that we studied 3 weeks ago, that z-scores tell me percentages, right? Remember, 68, 95, and 99.7. Okay. If I wanted to be 95% sure, my confidence level is 95% sure. So I'm trying to create a confidence interval from this 40, and I want to be 95% sure so I can tell Mary some useful information. Okay. I'm going to have to figure out what z-score, right? I have to figure out what z-scores make it so that I predict I'm capturing 95%. Like I estimate that the gap window that I'm interested in is associated to the likelihood of finding a fish that's close to the queen using this concept of 95% of the data is centered around the queen. I know that, hope it's making sense. I know it's wordy. I'm not even saying it in the best ways, but I'm trying, okay? That 95% confident is going to be based off of this. So I got to find out what z-score this is and this is. StatCrunch does all of this for you. It's beautiful. If I had to do it on my calculator, I'd have to jump through a few more hoops with you guys, right? But for StatCrunch, here's what we're saying. Actually, I'll pull up the number magically. Inverse norm, 7.5. Okay, the z-score, this magical z-score I'm looking for is 1.9599. Okay, so it was around here and around here. Those are the special numbers I need. Okay, so this is what it would look like. 0.40, 0.60, all over 10 square rooted times 1.9599. Okay. This purple thing will be given to me. Okay, so I'm probably wondering, why am I doing this? This is called the margin of error. You guys will have to learn what the margin of error is. It's the plus or minus added to your center statistic, the center of the confidence interval. Okay, I'm trying to create the window so I can tell Mary between what and what. Okay, this is the same value. I hope you can see that, you know, this and this is going to come out identical. It's just whether I add it or subtract it. Makes sense so far? Okay, cool. So let me calculate this little thing. 0.4 times 0.6 all over 10. And I get 0.36, right? Okay, this is really cool because what I'm saying is if I add 0.40 plus or minus this to 0.40, adding it, right, gives the upper. When I slow down like this, don't check out. It's important that you keep continuity of thought. I get as my upper value 0.736, sorry, 0.70. 36. And as my lower, I get 0.09. Okay, lower and upper. Okay, just so you know, I just created a confidence interval. These are where these things came from yesterday. So yesterday we're trying to tell you the story. Today and tomorrow, we want you to be able to create this, compute this yourself. Okay, so here comes my sentence, Mary. When collecting a sample of size 10 with 95% confidence, the proportion of the 115th Senate, the proportion of the 115th Senate that is Democratic is somewhere between 9% and 70%, right? That's a confidence interval. I just created it. I told you all the background theory to it, but that's because I found one sample fish at 40%, okay? And I created a window between 9 and 70%. So obviously that's a horrible estimate, but remember, right now we're only working with size sample 10. That's not even good enough for the central limit theorem. I'm working with the population of 100, which is not that great, okay? And I'm also being, okay, this is important. I'm confident because I gave a wide interval. You see that? Because if I start to narrow it, I'm going to be less confident about it. That's more of an intuitive concept. I hope everybody understands the intuition behind being less confident about smaller intervals, right? So, like Mary can say, hey, you know, that's still kind of useless. 9%, 70%, that's a big gap. Can you tell me a smaller, like narrower point of view? And I would say, yeah, but I won't be as confident about it because I could say it's between 38% and 42%, but I won't be sure, right? So let's do that. I'm going to recreate this with 80% now. Let's go with blue. If I were to do confidence level of 80%, then my margin of error, this thing, I won't show it on screen, but the only thing that changes is this number because I'm now looking for 80%. And I'm basing that off this z-score. So that z-score would be 12815. Okay. Using that value, I get a margin of error that's going to be plus or minus 0.1985. And that is still going to be added and subtracted to my sample. My sample never changed. I'm still collecting 10. I'm just changing my confidence level, right? So 0.4 minus that. So that creates a 0.2014 and a 0.5985. Okay. So I say, okay, Mary, well, I'm a little less confident about this, but I think I'm 80% sure that the queen fish is between 20% and 59%, right? And as you know, the queen fish is 47. So in both cases, I captured it, right? But, you know, Mary says, dang, 20%, 59%, 20 to 60%, that's still a huge gap. Can you shrink it more? I'm like, yeah, I can keep shrinking it, but I won't be as confident about capturing it. Do you get it? And so then I say, okay, let me make it ridiculously narrow and see if I can give a small precise value, right? So Mary, give me like, well, and this doesn't have to be Mary, it could be anyone else now. You know, what kind of window would you like me to give you so it's not so wide? It doesn't feel like useless information. You want 10%, you know, between 30 and 60 or 1%? Like, what do you think is a good value where you feel I informed you? Anybody? Do you get the question I'm asking?
35 and 45, or sorry, 55.
Okay, so you're saying about a 10% confidence, like sorry, not 10%. You're saying that the interval is about 20 percentages wide between 35 and 55, right? Okay, so that means there's 10% on this side and 10% on that side. So that means that the margin of error is 10%. Okay. I'm working backwards. You guys don't have to do this, but if it is 10%, then I'm going to tell you what level of confidence is associated with the margin of error of 10%, keeping all other things the same. Okay. I've never done this before. Wow. Okay. 5%. Okay, let me pick a color. I guess black. Confidence level of 5%. I would only be, dang, that sounds low. Let me double check that. Yeah, about 5.1%. 0.051. All right, give me a second. Oh, okay, yeah, I did mess up. Almost there, guys. Sorry. That gives me a z-score. I want to know the percentage of the z-score.
Are you gonna go over any of the problems from Module 13 today?
Yes. I hope so. I mean, sorry. I know that all this is leading up for us to understand those problems. 48%. Okay. Okay. I can then tell you if the plus or minus of the margin of error was supposed to be only plus or minus 10. So from 30%. Now you said 35 to 55, but just so you know, do you agree that 40 is not centered between 35 and 55? I believe it was Jade. I think I can't tell who spoke, but I think that was your voice, right, Jade? Am I wrong, guys? So someone told me between 35 and 55. That's why I went on this.
I think that was Samantha.
Samantha. Okay. Well, when she said between 35 and 55, just know that that's not centered on 40. She wasn't wrong, but I didn't specify she has to center herself on 40 because 40 is my statistics. This is the fish I found, or the statistic, right? So I'm just saying when she said 35 to 55, I understood she wants an interval of 20% is what would sound reasonable or useful information to someone. So I figured out that I can now shrink my interval and say, I went and found a sample of 10. I am 48% confident that the population proportion is between 30% and 50%. Okay? So can you see how confidence level is changing the width of these intervals? So on StatCrunch, these values here, they come from proportion stats, one sample with summary. We do a confidence level of 0.95. We have 4 out of 10 successes. You understand? I'm about to do the homework right now because this is probably what you're going to use. So I've already done like 3 questions similar to anything that any question that asks you how to do one proportion confidence interval. I just did 3, and I'm going to show you how easily it is to do it on StatCrunch instead of having to wait for me. Look, successes 4, right? I found 4 Democrats. I saw 10 senators. My confidence level is 95, right? All I have to do is hit compute. And look at this lower limit. Look at this upper limit. Does it match or does it not match?
It doesn't match.
It doesn't? What do you mean?
But like
It does.
it does.
It does.
They're different.
What do you mean? Are you guys looking at the same screen?
It's 0.9. He just didn't write all the numbers, but it's 0.9 and then 0.70. It matches.
Right. You guys are weird. What when you guys see decimals, you guys start cutting those things off, and then we tell you be precise. Don't skip any of the decimals. You're like, why? What's the big deal? Okay, so the moment I cut the decimals out, you guys are like, no, it's completely different.
I don't know if they were thinking of like rounding it.
You see 2 different answers. Like
Okay,
the lower 0.09 and then the upper limit's 0.70, and they have, a bunch of different numbers. Because you're asking if they're identical, right?
Yeah, I guess I shouldn't have said if they're identical. And when I say same is kind of like identical. I hold identical as really meaning exact. Are they the same? They're kind of the same. And are they similar? Fine. Are they similar?
I mean, they're both decimals, but there's like
Hold on, are you
0.09.
Joshua, are you looking at the same screen? Because now it's starting to bug me. Do you see the 0.9?
Yeah, I see that 0.09, yeah.
Do you see this is 0.9?
Yeah, it's the same. But you're talking about the lower limit and upper limit, right?
Yeah.
So that's lower limit would be L limit, and would the upper limit be U limit, right?
Yeah, but I don't. Yeah, but why are you worrying about the L limit, the U limit? But I get it. I should have told you what's what. But
because the answer ones were the same. So I'm assuming that that would be lower limit and that would be upper limit, and the numbers don't match.
They don't match or they do match? That's what I keep.
They don't.
They do. Why do you keep saying they don't?
Because the L limit, you says lower limit, right?
Hold on.
The-
Is it me? I don't mean to argue.
I don't
I'm
know.
saying, is someone seeing something different from me?
I'm pretty sure we're seeing the same thing. I don't know if we're just talking about the same thing.
Are you telling me that this 0.09 is not the same as this 0.09?
Yeah, those are the same. But
So what's so hard about that?
I'm looking about the chart.
Were you comparing the lower limit and the upper limit?
Yeah, because I see where he's.
That's what I'm saying.
That's why I said it was different.
What's
That's because
different?
that's what you said.
Look.
He was
Is
comparing
this
the lower.
hold on. Is this 0.703 not the same as this 0.7036? Now, I just added the decimal, just so you know. And so I'm not gonna
Yeah, no.
act like I snuck that in right now. But are you still telling me these are not the same?
Yeah, sure, those are the same. But they're
Well,
comparing them
then
on
that's
the
all I'm talking about. That's all
Oh,
but on the chart.
we thought
What
you were.
chart?
Now that makes sense. But
Yeah,
I feel like everybody else was
you said
thinking
to compare.
about the chart.
What are you talking about? What chart?
They're
The
looking
chart
at
that
the
you just
chart.
circled.
Yeah.
I'm confused. Where?
They're
Okay.
looking
We're
at the
thinking
summary
that
chart.
like the lower limit and the upper limit were supposed to be identical.
Yeah.
But you're really comparing them off the chart. It wasn't very clear, at least to me.
Now I get it.
Yeah, now it makes more sense.
Well, you thought I was comparing this and this?
Yes,
Yeah,
that's what I
that's what
thought.
they
Why?
thought you were comparing.
Because it wasn't very clear. You were just kind of like saying lower limit and upper limit, like it was those two. And now you're comparing to these that were off the chart. So it was like,
Oh, did you miss the part where I said I'm about to create these intervals on StatCrunch so you don't have to do it by hand so you can see?
oh no, I saw that. And then you said, are the lower limit and the upper limit the same? And then so I saw the lower
Okay,
and upper limit on the chart. And then it matched.
got it.
But they matched the ones that are off the chart.
100% right. Actually, I take back
So-
everything, all my frustration. I did not say, are the lower limits and upper limits the same as these lower upper limits and upper
Yeah,
lower?
that's what it was.
You're right. 100% right. 100% right. When I say two things are the same, I only name these two. My bad. I just thought I thought that when I said I'm going to use StatCrunch to demonstrate how to do these things, that I know you know the vocabulary that these are all lower limits and these are all upper limits.
Yeah, making that clear now.
Okay, cool. My bad. Okay, so do you see how StatCrunch saves you a lot of time?
Yes.
Okay, so that is with 95% confidence. And
Do you mind going through that just one more time?
Okay, so I'll do it again. I'll do in blue.
Yeah, just the steps.
Okay, I'm gonna do the blue one now. 80% confidence, right? I know there's a lot of writing on the screen, but I can't erase it. So where you go is stats, proportion stats, one sample with summary. You will put the number of successes and sample size. So my sample size, I saw 10 observations, right? I found 4 Democrats. My confidence level is now going to be 80. So I know you can't see it, but I put 80 here. And that's all you do. Hit compute, and you get another confidence interval. And you can see it's 2014, right? And 5985. Does that make sense?
Yes.
Okay. And I could narrow it down. Now, obviously, I've still captured the queen fish of 47% in all 3 of these, right? Now, this is not because of the central limit theorem, and again, not collecting sample sizes that are large enough and not having a large enough population, okay, then I can't create a confidence interval that doesn't capture the fish right now. Like, like I could create a confidence interval that doesn't capture it, but so let me adjust it. Let me explain what I mean by that. I actually can create one. I just feel like the confidence level is so low that no one would really try to create or report such confidence interval. Data summary 4 out of 10. And then let's go with 30% confidence. Okay, there's one. See? I am 30% confident that I just caught a fish that I can use to create a confidence interval that says I am only 30% confident that the true population proportion, aka the queen fish, is between 34% and 45%. See, I missed the queen fish, the 47%. So you can trust me, and then I'll say, yeah, but remember, I was only 30% sure that I would. You get that interplay between confidence level and capturing the fish and the width of the interval? Okay.
So it doesn't count as capturing the queen because the number is 0.474, and so your upper limit is only 459, right?
Sorry, no, don't look at this red 4. Yeah, hold on. Don't confuse this 475, this 474, and this 4702 as being the queen fish. The queen fish is 47% because we went and looked at 100 senators, right? I'm trying to and counted all 100 senators and got 47 over 100. So obviously yellow is the worst color. I wish I had red, but I don't have any more reds. Oh, actually I have a dark red. This is the queen fish. Okay?
Okay.
You hear what I'm saying? Right?
Pretty much it captures the queen fish because it's just short of it.
Right. And just so you know, these were estimates through experimental trial. But those are pretty damn good that they get close to the fish. But to do that, you have to carry out 200 samples. And so once again, that becomes impractical, right? Think about what that's saying, right? If I carried out 200 samples of size 10, you should ask me, you're an idiot. I mean, sorry, you should tell me I'm an idiot. And you should say, why didn't you just go talk to the 100 senators? You get that?
Yes.
Okay. Does everyone get that? Size 10 samples, 200 times. That means that I went through the labor of 2,000 questions. Are you Democrat, Republican? Are you Democrat, Republican? Put all that effort and time. You should have said, yeah, you're a fool. Just go talk to the 100 senators, ask them and figure it out already. Right? But I want you to know that these confidence intervals, these are based off one effort, simply the 0.4 sample, right? Oh, I don't even know when that got shifted, but something like that. Yeah, there we go. Do you get that? These are estimates through a lot of experimental trials and sampling, way more effort than just finding one sample. So clearly, if I put all that effort, I should be able to find a good estimate of the queen fish. but merely using one sample of 0.4, I'm able to make these estimates based off these levels of confidence in my estimation. So again, this black one, I could say I am 48% confident that the population of Democrats in the 115th Senate is somewhere between 30% and 50%. And that only took one sample. Is that making sense, guys?
Yes.
Okay. So we are ready for homework. Going to clear all this. I don't know if any last questions about this, clarifications? No? Okay. I'm clearing. Okay. So, I don't know who stuck around. Some of you came in halfway through that long discussion. The only ones that stuck around. Okay, the only ones that stuck around are you guys. So you saw the people who came in and left, right? I want you to know that's what it feels like to be lost. Meaning, that's what you guys feel like when you walk into lecture tomorrow morning, when you don't read the book, right? Like what I'm sorry, side note, I'm trying to tell you how to be a good student. It's not their fault that they left. I'm not even saying that. They shouldn't have stuck around, really. But it's walking into a movie 30 minutes after it started, right? Imagine if every single movie from here to the day you died, you always miss the first 30 minutes of the movie. You're not going to be a fan of movies. You're going to be like, oh, they're always so frustrating, right? That's what a math class is like. You're supposed to have like 10 years of math skills right now. From high school, from kindergarten to the day you graduated high school, you guys need to understand percentages, proportions, fractions, inequalities. And now you're stuck in this class. And when you're missing those skills, that's why it feels like a bad movie, right? Like, I understand how difficult math is. I'm only okay at it because my fundamentals are all there. Okay, so just letting you know, you guys should feel like the A students right now, because you understand. I'm talking to you guys. You're hearing my conversations, and you get what's going on. And those other people, not their fault, but missing that information makes it so like this is a meaningless conversation, right? So you check out, and that's what lectures are like. When you're in lecture and you can see those people responding and replying, right? Because they get it, and you're like, well, how come they're having that conversation? They're speaking another language that I don't know, right? I just wanted you to at least, I want to share that with you. Even though there's only 5 of you, that's what it's like from class to class to class always, okay? So we are ready to do homework, and we have a lot of tools and hopefully imagination, right? So here goes. Random sample of 280 adult Americans are surveyed. That's my sample size. And I found that 86% of them have driver's licenses. I just caught one of my orange statistical fish. I wonder, question mark, side note, who thinks that the queen fish is 86%, right? Who thinks that of all Americans in the entire country, 86% have licenses, right? Because that would be something we would want to know, right? Again, why would we want to know that? Hey, I'm the Department of Motor Vehicles for the state of California. Of course, this is for the entire US, but maybe the consensus, right? Sorry, not the consensus. Is it the census or the consensus? Now I'm forgetting words now. Okay. If you wanted to know how big of a department you want for, Department of Motor Vehicles across the nation, you'd want to know, hey, do we have like a high proportion of adult drivers or not? You get what I'm saying? Like, You could even say, like, we want to build a whole new train system. Like Elon Musk trying to create the Hyperloop from various cities to various cities, right? What happens if in the next 15 years transportation in the US gets transformed because someone says it's worthwhile or not, right? So right now, if 100% of adults had a license, and you're like, maybe they won't want to change their driving habits, right? If 0% of them have driver's license, or say, hey, it's easy to adopt a whole new way of transportation, especially if you're not stuck in one, right? You get, these are very contrived questions I'm making. The way I'm making them sound too narrow, but I'm trying to give you insight into why would we want to know this queen fish statistic. Parameter. Queen fish is a parameter. Okay. So 280, caught them, study them, 86%. What scenario allows for the estimation, would this scenario allow for the estimation of P or mu? Anyone? Hello? Someone said something.
P.
Yes. Okay. You guys agree? Or do you
Yeah.
guys not know? I heard a yes for agreement. Anyone like not know what we're talking about? I'm saying not know what we're talking about. Like, it's okay. Right now, just say, I don't even know what P or mu is.
I know what P and mu is, but can you explain to me why it's P?
Okay.
Does that make sense?
Okay. So, give you an example. You know what a male or female is, yes?
Yes.
Okay. Actually, this might get weird. Well, hopefully it doesn't, but I'm trying to use basic information. Do you know why I'm a male?
Yeah.
Because obviously the distinguishing factor would be obviously sex, right? But right now, I am male. I'll confirm to you I'm male. I also have, like, I guess, male expression or voice or facial hair, and a lot of things point to that. But I mean to say is, if you know what a proportion is and you know what a mean is, you have to see if these things get the check marks to be a proportion or mean. So I'm saying I got the check mark. Oh, he has a mustache, or his voice is a certain way. His name is Joel. And then you classify me as male. I'm saying, what does it take to be a proportion? What does it take to be a mean? So that we can know if 86% of them, of the 200, is a proportion or mean, right?
It's because it's a proportion of the population, which is what P is. Okay. Makes sense.
Yes. 86. No, that's okay. It's okay. So, but I always remember, I try not to give the answer, but if you stick around, eventually I do. Okay, so the 86% of means that there's an X here, an invisible X, 280 people, and I asked 280 people, do you have a license? Yes or no? Yes. Do you have a license? Yes or no? Yes. License? No. License? No. License? Yes. I kept going through this process, and I got a bunch of yeses, and it computed to 86%, right? I hope someone right now can tell me how many yeses I got. These are all prerequisite skills for the last 4 weeks, right? You can see how everything's starting to come together now, right? Okay, someone tell me, how many yeses did this surveyor get?
$241.
Cool.
Well, roughly 241.
Okay, no, that's good. It might be a rough situation.
Is
A
it
rough
240?
estimate. Yeah, 240.8, right? So yes, exactly. So let's call it 241 because I need a whole human body to give me that response. You get what I'm saying? Okay. So I want to point this out. You guys get frozen and stuck every time you're not given information clearly and directly, right? If I were to say, I don't have a wife, I write that down. I ask students, can someone in the class figure out if Joel is married or single, right? Some of you are saying, oh, I can't figure it out because he hasn't said he is married or is single. You get what I'm saying? You have to start to push for the information. Right now, just because I didn't tell you 241 respondents replied yes to having a driver's license out of the 280 does not mean you should not be able to go find that information. You know why? Do you guys recall how I got the confidence interval 10 minutes ago on StatCrunch? Do you remember what it asked me? Do you get what I'm trying to get at? Who has
You
a...
mean like the successes and the samples and stuff like that? Or no?
Yes. Who was that, Jade?
Yeah.
Okay, cool. Spin for you. Just writing it down for you. There are my successes. There are my observations. If you guys don't have the skill set to determine that's 241 yeses out of 280 is what gives you 86%, you're gonna get stuck on that stage. But you have to flow with it, right? So like the fact that I said I have no wife means, well, I'm legally single or I'm not married, right? So you give information and you're supposed to come to conclusions. You infer, okay? All right, so this is a proportion since we have 241 out of 280 respondents replying yes. Look at this. Construct the 95% confidence interval for the parameter you chose. Have you guys been told how to use this formula? No. Right? So you're probably not going to use it. You're going to rely on StatCrunch. So do you see all the effort I put in for the last hour, 2 hours? We're ready to go. StatCrunch. New window. And the whole story is there. At least I hope you see it. We found one bundle of fish, and I'm trying to find this queen fish for the entire United States. And how confident can I be? I'm going to be going to calculators, proportion statistics, one sample. With summary, I have 241 successes out of 280 sampled. I want a confidence interval of 95%. And this thing is going to construct this formula over here. Obviously, again, it's just going to do it for us, nice and easy. But there it is. Like, hey, Department of Motor Vehicles for the entire U.S., if there is one, I'm making it up. I went out, I did some research for you. I talked to 280, got 86%. I am 95% confident that the true population proportion of Americans with the driver's license is between 82% and 90%. And I didn't have to talk to 300 million people. I didn't have to take multiple samples. I'm just basing this off one concept, the central limit theorem, right? Now, I'll tell you where I failed right now as a tutor, because I didn't do it in the order I should have done it. Did I check the central limit theorem conditions? Because if I didn't, this estimation is BS. Because I don't even know if the distribution is shaped the way it is. I don't know if the fish I found could be way far away from the queen. You get that? Like I'm basing everything off my idea, my theory that any sample I get is close to the queen parameter. So let me backtrack a couple steps. Let's go to checking if the central limit theorem applies. Did I collect my samples randomly?
Yes.
Cool. So 1 gets a checkbox. 2, do I have at least 10 successes and 10 failures? Yes, right? You can see that in NP and NP hat. So technically this is a P hat because we don't have a P, a proportion for the population. If we did, we wouldn't even be doing this study. You see the difference? I'm just saying, like, the formula is NP greater than 10, NQ greater than 10. But if we had P, we wouldn't even need to do this estimation. So our next best attempt is to use N. Sorry. Oh, I'm learning something now. I'll store it for later. There's a difference between hypothetically going out and collecting and expecting a result. That's when you're often calculating this. And the central limit theorem you don't have to calculate this because I clearly got more than 10 successes. It's already done. It's a matter of fact. I got 241 yeses and about 39 no's. You get that? Okay. So let's get the checkbox. And 3, right? Do you think that there's more, question mark, do you think that there's more than 2,800 adults with licenses? Cool. Checkbox. Okay. Now I'm back. And the legit theoretical the steps were taken, and now I can tell, yeah, I am 95% confident that between 82 and 90% of all Americans, adult Americans, have driver's licenses. Interpret the value you made in part B. I verbally stated it right now. It's on camera. You recorded it. Do you want me to type it out, or are you guys good?
Could you type it out?
Yes, please.
Okay. Oh, I remember my numbers.
0201.
8201 9012. You guys write it down, read it to me as I jump over here. Right? And what was the other one? No? Oh, what? 801?
201.
8201.
8201. And then it's 0.9013.
Okay. So there's the confidence interval. There's not really much else to put. You could write it that way, or you can write it like this, which is 0.8201 P 0.9013. Okay. Interpretation. We are 95. Now, this whole interpretation business, I'll be honest, I'm a little bummed out that I have to write it because that's what yesterday was about, right? Didn't you already write 3 of these? You were given the information and then you wrote them yourselves with practice. Just say
Yeah.
Yes or no? Okay. All right. I just want to hear that you know that you did get the practice. And so right now, if we did a quiz today, that means you didn't master that skill by today, which is fine. Obviously, it's only been one day, so um, but that's why we teach it in the order that we teach it, right? We want you to be able to understand this sentence and this phrase. We are 95% confident that the proportion of adult Americans who have a driver's license 82.01% and 90.13%. That's one way of writing it. Another way of writing it are with 95% confidence, the proportions between 82.01% and 90.13% contain the true proportion of adult. You realize why I have to put adult Americans as opposed to just Americans? Like you have to be precise about the population. So this is obviously excluding 15 if with the permit, but I guess 16, 17-year-olds. We're talking about 18 or over year old. Like it's more precise. And I can't just say adults because we're not talking about adults in Brazil or anywhere in Europe. You get what I'm saying? Okay. Adult Americans who have a license. Why can't I? Okay. There we go. So I know you can't read this because it's super messy, so let me highlight it like this. So there are two ways of writing the same sentence. Confidence level, the parameter specified to the population in question, and the boundaries. And the key word being between the lower and upper boundary. You understand? So I'm trying to do one problem thoroughly. I know it's taking long, but this is, all the other ones are just going to be a rinse and repeat, right? Like, except for the mean ones. I haven't done the mean one. Okay, so I'm moving on. Are you guys good? Okay, that one. I'm going to clear my screen. In a recent survey, it was found 53.62% of Americans eligible to vote who actually do vote. Sorry, I misread that. We found that 53.62% of Americans eligible to vote actually do vote. Okay. 1,000, I don't want this bubble. Oh, geez. It won't let me. Sorry, guys. I'm trying to get rid of this blank space. And I can't. There we go. Okay, cool. 1,932 were random selected. Would this scenario be an estimation for P or mu?
P.
Good. Construct a 99% confidence interval. Someone go do it and come back and report to me. Alexandria. We're doing number 2 right now.
Do you want me to give you the lower limit and the upper limit?
Yes, as soon as I get my lower. Okay, yes, go ahead.
0.5070 as the lower limit.
Uh-huh.
And then the upper limit is 0.5655.
Yep, I agree. Five zero 70, comma 0.5655. Okay, interpret the value. Interpret the interval. Joshua, did you get the same value?
No, I'm still trying to work out the stat crunch.
Okay. Okay, I'll show. I'm going to. Well, I'm already sharing my screen. I'm going to do it. So.
No, it's what stat, portion stat, and one sample, or
One data,
summary.
one sample. You have data or summary. Go to summary. In the successes. How many successes will we put?
Well, I was using your screen for the PDF, so I have to go do mine.
Okay, no, I'll go back.
All right, cool. That'd be better.
But yeah, obviously I have pencil and paper right now, so then you could like jot things down or type it into your calculator. So, and Alexandria, just I know you came in halfway through. I don't want you to feel left
I got
out.
1,035.
Okay, but I didn't. So why is that?
I don't know. I multiplied the 1,932 by 0.5362.
Right.
Right.
And what did you get?
1,035.9384.
Okay, so you get. I guess I'm trying to hint without giving it. So what do you think you should do?
Well, he said it's not right. Right?
Yeah. I mean, well, I got 1036.
Oh, so just round up, pretty much.
Well, why did you round down?
Why wouldn't I round down? Because it's like 0.1 away from going to the next number. That's why I round up.
Right. So do you get what I'm saying? Like that's what I mean by like a previous skill. So do you make the call to make it 1035 or 1036?
Oh,
wanna know-
1036. That's
okay.
rounding up.
I know, but I'm not. I guess what I'm trying to say is there is no right or wrong to rounding up or rounding down. I'm just saying, on what basis did you make it 1036? It's 1035,
Oh.
right? Like on what basis did you make
So
it?
it doesn't. Repeat that one more time.
Like why did you so confidently say 1035? Why didn't you even pause to at least ask me, hey, I got a decimal, what do I do with it? Or why didn't you make it 1036? Like do you get what I'm saying? Like why did you make it 1035?
Oh, I mean, it was the first number that popped up, so I just kind of said it as I calculated it.
Right.
Pretty
So
much.
skill set that I would encourage is read the whole value and then think about the context. Can I have a decimal of a person? No. So you made it 1035. That's a good reason to make it 1035, a flat number. But you didn't read the rest of your digits on screen and didn't like contribute your past mathematical knowledge. Don't you always go up for 0.5 or higher and then round down if it's under 0.5?
Yes.
Okay. So
does it really matter then if you can argue both sides?
no, you can argue both sides. I'm saying next time around it could come out to 10.
So does it really that?
Hold on. There is a right, and you can't argue for both sides, unless we establish. Are you going to use the rounding skills that have been taught in previous years of math? Right. If you see 10.34, what are you going to say? Sorry, 1035.4.
10.4, probably say 10 people.
Yes, and if you see 10.9?
Well, you could round up mathematically and say it'd be 11, but logically, you can't have 0.9 of a person.
Right,
It'd
but
still
you can't
technically be 10.
But
right?
you can't logically have 0.4 of a people either. I get, okay,
That's why it's still 10, right?
No. Okay, so ready? It's fine.
10.4 isn't 10?
Joshua Bustamante does not use the conventions of rounding, period. And that's okay. I want to encourage you, we should. But you're right, we don't have to, but I don't know why we wouldn't if that's a convention that we use. 10.9 should be 11, 10.4 should be 10. When we're talking about rounding to nearest whole number.
Okay.
Right?
So just always round up, pretty much.
No, literally, if it's 10.4,
so the point of
10.
arguing for both sides, that's what I'm saying, like rounding up past a certain point is what I meant. But it's like, you can't have, like, what does 0.9 of a person look like?
What does 0.4 of a person look like?
Nothing. That's why it's still 10, right? That's why I'm saying 10.4 equals 10. You could still argue 10.9 could still be 10.
No.
Point
we are arguing. Okay.
Doesn't exist.
No. I get it.
Okay.
I'm answering your question with the question. Meaning, I want to know on what basis are you not saying 10.4 exactly? You're choosing to go down, right? But I want to know why you're going down. What you get what I'm saying? I'm questioning the reason. I'm never worried about the answers, right?
Not worried about the answers.
Yeah, I'm never worried about the answers. I'm always worried about reasoning.
Yeah, that's my reasoning. You can't have a decimal of a person. So you can't have like 10.4 of a person, 10.9 of a person. I mean, you can't just add a person for the sake of that. So that's what I'm saying. 10. If it's in the 10 range, it should probably be 10. Or at least that's how I'd argue it. And you say, in stats, we could argue for our reasoning.
Okay. No, I agree. Okay. So are you trying to tell me that? No, that's good. That's good. No, and I like that. I actually do like that you back and don't back down. Because I'm asking for the reason. So, okay. So from what I understand is 0.1, 0.4, 0.9 of a person never counts at all to you until it hits the next digit.
Pretty much. I mean,
Okay.
if you just
No,
want to
that's
round
good.
up.
That's good. No, that's good. That's good. I get it. Your rounding style, your
Okay.
convention, it actually has a name for it. It's called truncating, which is fine. It's
Oh,
another legit
okay.
version of reasoning. Okay. So usually we will round up if it's 0.5 or higher and round down if it's 0.4 or lower. Does that make sense? And like
It was kind of cut off there. Can you repeat that one more time?
just round up if it's 0.5 or higher, round down if it's 10.4 or lower. So just use the regular rounding conventions when finding these proportions in, right?
Okay.
So because we got
So then you can't really argue for your answer if you're looking for a specific answer, right? It has to be rounded up pretty much after 0.5.
that's the reasoning, yeah. That's the arguing that I'm saying. Like that is the convention for rounding. But you can truncate if you want. Yeah.
So would I be wrong if I did it my way? Because you said I can do that if I want.
Well,
then why would I want to do that?
Yeah, I know. So what I mean is, would you be wrong? Yeah, you would, because like if you take 100 of us in this math class, people are going to be using rounding that they've learned since 5th grade.
Yes.
And I think it'll be rare to find people that will take 10.9 and make it 10. So it's more of it's a conventional thing. It's like there's no right, like now we're getting into like the I don't want to stifle people's learning, but I'm saying like, you know, if you spell the word color C-O-L-U-R-E, you wouldn't be wrong, but would be more of a British styling. And you just don't see people use that often.
Yeah.
So like culturally, I guess we do have different concepts, but I mean to say is like.
You're saying I would be wrong.
Well, I guess I would start to question where you got educated then. Like, did you go to a school system that taught you how to truncate at all times? I mean,
no,
like if I see a person walking down the street, if I see a person walking down the street and spell the word color with L-O-U-R, I would just think, oh, a question: is he American, or is he British, or is he from some other culture, conventional? That's why I'm saying that it's convention. I'm not saying it's right or wrong, but when we start to explain for the reasoning, your reasoning will justify it, right? So like, hey, why do you spell it the way you spell it? Oh, I was raised in England and that's how they taught me how to do it.
Okay, so I could get it right if I just explain it, is what you're saying.
Yeah, you would have to say, I refuse
like, it
to
just happened
round.
on exam, like just scenario in this class.
Yeah, I would say.
Or just saying you can't have 0.9 of a person. Or sure.
You say I can't have 0.9 of a person and I don't round.
Well, in real life, you can't round the person, just like add one to the equation, right? Logically. Taking a statistic. You can't just like add someone to the sample just because it's 0.1 for one side when in reality, right?
Well, you can. Well, we can because we all agree to the rounding scheme. Like the class is using rounding as a background information is what I'm trying to tell you.
Okay, so just from now, all right, so I can't even argue it. I wouldn't even try to argue it. Just on the test, I see it 0.5 up, rounding it. It's a little.
No, you can argue. I'm just saying it's going to be like you're going to have to. We're spending too much time. It's my fault. It's just I'm sticking to the fact that there's no right and wrong, but there's a convention and a style. And you keep saying there's no right and wrong, and I'm trying to get to explain like, well,
I'm not saying that. You're saying that about you just got to argue it and there's no right and wrong. I'm asking if I could argue it that way and I get it wrong.
You
You
could
know what I'm
argue
saying?
it, but you would literally be saying, I am not rounding. I am refusing to round. I am choosing to make it 10 because I perceive all fractions to not matter.
For this class, shouldn't we be rounding anyways? Like, isn't that something we should be doing?
Well, yeah, that's what I've been trying to say the
Yeah,
whole
that's the
time.
thing. But it's like when we're rounding a person, you saying we could argue it both ways. Like, sure, mathematically, the way I've
He's
been taught, you're
just
supposed to
saying that
round.
hypothetically so he can like.
No. A person, no. We're not
I'm just
rounding a
saying
person.
that because I'm trying to prove my point. Like,
We're not rounding a person. We're using rounding the rule that we learned in 5th grade.
okay, but you're saying we could argue for either side. So in that scenario,
Yeah, because I'm trying not to stifle your learning. I mean, I can tell you you're wrong, but I'm trying to say, no,
yeah,
I don't.
just tell me if I'm wrong, because I need to learn from this, because then I get to these points of confusion. It's like,
Well,
okay, I can get this and
that's the
still argue.
problem.
You know what I'm saying?
I can't tell you. That's the problem. I can't tell you you're wrong. You can truncate, but you have to acknowledge you're truncating and you're not rounding.
Wait, why can't I be wrong? And isn't there like a right way and a wrong way to do things?
Only when it comes to like calculating math, but not to conventions in life.
Okay, but this is where both kind of paths kind of meet. We're trying to take a convention of life and make it a math equation. So that's what I'm saying. You can't have point this of a person, but then you're saying I can't because we have to round up when you're trying to compare the convention of life, to a math problem.
Conventional
saying?
math. No, conventional math education system to conventional math environment. This class.
Okay, so now it's conventional math environment.
Yeah, which I thought it was assumed since, we don't assume that you know calculus right now, but you might have learned calculus at the 10th grade level in India. We don't assume that you haven't learned calculus. We assume based off all, K through 12 education in the state of California. The convention is rounding.
Yes, but okay, never mind. You're just saying how we could argue for both sides. So that's how I'm a little confused right then and there. You know what I'm saying? But
Yeah, you
there
can argue
obviously
both.
is a right.
No, you can argue. It's weird because it feels like you're arguing, but now you're saying that I'm arguing on your behalf, and you don't really care. And I'm literally trying to tell you is you could say 10, you're just not using the math skills that you're expected to use in this class.
But would I be wrong on an exam? That's all I really care about, pretty much.
I get it. Yes, because you would be judged by the standards and conventions of this class and this
Okay.
education system.
That's what I needed. Yes, right there.
Okay. Got it.
Thank you. Just anything that applies to the exam, anything that's going to increase my grade. So that's what I need to know.
Okay. See, I feel bad because you just only want to know what is good or bad for your grade. You see, I was going through all that simply because I didn't want to tell you you can't do it. And now you're telling me that's all I care about. It's just my points. I don't care how I learned, what the context is.
Pretty much.
Yeah. I didn't expect that. I don't expect that from any student. But I get it. Okay, so we have, and this, just so you know, sorry guys for everyone who stuck around for all that. It's just, I'm big on ideas and philosophy. I'm actually a philosophy major. And so that was my personal issue. I shouldn't have wasted your guys' time. But you can see that it's how we want to prioritize point value system for what's right and what's wrong. Okay, so you do understand though, like this is part of the learning environment.
Yes, but we're learning like philosophy in a way.
Now you know. Now you know what. Yeah. Math and philosophy is very important. So now you know what is expected of you, right?
Yes.
Like literally, like from K through 12, you're supposed to know rounding. From K through 12, you're supposed to know your times tables. From K through 12, you're supposed to know your decimals, percentages. Some of you are messing up 0.01 or 0.001. This is a big concept. Most of the people in your class have no clue what they're supposed to know before they step into this class. But this is what I mean by conventions, right? So we'll round up, we move decimal places, you don't calculate with percentages, right? So right now we have 1035.9 rounded up to 1036. So the successes would be 1036 in StatCrunch. Is that the right number? Because I already forgot.
Well, mathematically, yes.
Well, not mathematically, by rounding. Just say rounding, because
Oh, we can't have it philosophically.
no, you could have it all. Philosophically, you could have any answer.
Yeah.
But mathematically, you can round or you can truncate. There's more than one way to adjust a decimal. So rounding according to the conventions of this class. 1932. 1932. Confidence level, 95 or 99? 99. And you get the answer that Samantha got half an hour ago. Right?
Say that one more time.
This is the answer that you got, Samantha?
Yeah, sorry, I was on a different problem.
Yeah, I know. It's okay. Is that the answer that you got?
Yes.
Okay. Interpretation. Anybody? I know you're probably, if you're working on other problems, we'll catch up soon. So
We're 99% confident that the proportion of Americans eligible to vote actually do vote is between 50.70% and 56.55%.
good. Sounds perfect. Okay, can you conclude that the percent of Americans eligible to vote who actually vote is greater than 50%? Why or why not? Anyone? This is something I haven't taught yet, but I'm wondering if we can
Yes, because the proportion is between 50.70% and 56.55, which is higher than 50%. So therefore it's greater, right?
yeah. So the way I would, yeah, okay. And that would be good. And so to add to that, I would say the reason for it is, yes, it's because both numbers are higher, but it has more to do with the previous long story I gave. That when you collect a sample fish, you have a certain confidence. And the confidence level, that 99% means that if I were to repeat this sampling method 100 times, my interval, my net, 99 of my nets would contain the queen fish and one would miss it. So what we're saying is 99% of the confidence intervals, if we repeated this, Wait, actually, I'm mixing two ideas. I'm mixing the idea of concluding that it's more than 50 and the likelihood. The number of intervals, sorry, this is one of many intervals that lies greater than 50. And so 99% of the time we think that the interval, no, I'm having a hard time phrasing it. I'm trying to explain that if it had values below 50% and above 50%, then I'm actually having a hard time because I can't say it's a probability. Most of the times, or that sounds like a probability. Some of the intervals, dang, I can't make the sentence. Let me try and think why I can't make the sentence. Every confidence interval, if I have 100 confidence intervals, some contain the fish, some don't contain the fish. If we are 99% sure that it does contain it, that just means if we repeated the process multiple times, the intervals will contain, and they're set somewhere. Oh, okay, I got it. I'm ready if you guys want to pay attention. 1% of the time that we construct intervals would be outside of this window. So it is a rare it's rare for the population parameters to be outside of this interval. There we go. Does that make sense? So it's rare for it to be lower than 50 or greater than 56. So there's a greater chance that it's in the interval, and all those interval values are above 50. And the easy explanation is what Samantha gave. Okay, number 3. Quality control engineer is looking for defective parts. Randomly samples 45 whiz cranks from the production line and finds that 4 of them are defective. Is this estimation for P or U? You guys there? I know you guys are all working independently, but is this a proportion or is this a mean?
Proportion.
Okay. Four out of 45, 90% confidence. 4 out of 45, 90% confidence. Done. Oh, I didn't change something. There we go. Oh, 19, 15, 9. Any questions while you guys, yeah, I guess, well, we stopped working together, but that's fine. So,
I have a question.
uh-huh.
So, can we actually do a problem on the confidence intervals practice?
Okay.
Because I think that one's due tonight, and that homework for mod 13 didn't have a due date, so I didn't know.
Okay. I assume it's on Canvas, right?
Yeah.
Okay. Okay. Samuel Morris, father of more. Oh, sorry. Question. I was going to start working from the top. You want me to work from the top, or do you?
Well, I know some people already did it. Which question do you guys want?
I honestly didn't even understand like from the beginning. But if
Okay,
Yeah, I was very confused.
somewhere else. Yeah, just start from A, please.
Okay. Samuel Morse, father of the Morse code, thought that the letter E was the most common letter in the English language, with a frequency of 0.12. Pause. What are you guys picturing and envisioning right now?
SOS.
Okay. Anything else? I mean to say, sorry, let me start off by saying, I am about to show you how to do a word problem. To do it, I have to demonstrate. I am demonstrating by starting to read a sentence and stopping at the end of the first sentence that provides information. The problem with word problem is everyone just reads the whole thing from start to end. You get what I'm saying? Don't read a whole paragraph if you don't even understand the first sentence. There's a guy who invented the Morse code who believes the English language uses the letter E the most. That means on this page, he believes you'll find E's amongst here the most. That means if I go to any document, anywhere with the English language, you will find E's at a 12% rate. You understand? That's what he is literally saying and believing, right? As soon as I find it. Okay, so to see if this is true today, a sample was randomly taken from a modern book, and 118 out of the 876 letters were the letter E. You get that? Hey, do you have time to look at every novel, every article, every newspaper, every text ever sent, every love note sent between lovers, every street sign? You don't have time for that, right? So he went and sampled just one section of a book, counted the E's, counted the letters, found 118 were E's. You see that? So 118 divided by 876. Did this sentence tell me to go divide 118 by 876? No, but I'm taking the initiative. You guys have to practice doing that. Hey, that's 13.47% or 13.5%. You see that? It's just a sample. So he believes something. I found a sample that says otherwise. But if I construct a 99% confidence interval, I'm wondering if my sample can estimate the range to support or not support that guy's assumption, right? What parameter are we trying to estimate? A mean or a proportion?
A proportion?
Yes. What is the value of the statistic in this scenario? I'll take responsibility for you guys not knowing, in the sense that I must have not conveyed what a parameter is and what a statistic is. course, this is not on you, Alexander. But before you came here, I gave a big, long discussion about what the class is trying to do as a whole. Between the Gettysburg and the senators, a population and sampling and creating statistics from that sample. So you guys really don't know? Sorry, I shouldn't ask with that tone. What can I do to help to guide you here without trying to give it away? So like, you have to ask a question for me to help. So I'm wondering if you know what this is. I'm wondering if you know what this is. And if you really understood what this was. And the fact that this, why can't I select my own writing?
I think value is what's throwing me off. I don't know about anybody else, but looking at it, I understand like proper notation is when you're referring to like the words that sound all smart from the statistic stuff, right? And then statistic is what we've been messing around with, but like what is the
And
value?
that's based on data, right? The statistic.
So a statistic is a numerical thing. So of course the word value would be associated with a numerical thing. What is the number? What is the value of the statistic in this scenario?
Oh. Would it be the frequency?
Okay, no. So it's really something like, so do you recall when we pulled a sample of 10 senators from the 100? We pulled a sample of 10, right? Okay, I'm curious. Do you know when we say what parameter, we have two parameters called proportion and mean?
Yeah.
Right? Okay. And when we pulled the 10 senators, I thought I discussed how that's p hat. Yes?
Because that's the sample proportion.
Yeah.
Okay.
And that sample proportion value is a statistic.
So what is the value of the statistics in scenario would be the 118 out of the 100 or the 876 letters?
Yeah.
That was more complicated than that. But then what does mean proper notation?
I'll show you. How do I write? What sorry.
Like the
go
third
ahead, Samantha.
Oh, the third over, like from the left of the column where it starts, there's a T. No, there's a T. Like where you got your little pen, there's a T.
Yeah.
I think that's the text so that you can type. Go over. Keep going.
This one?
Keep going. The furthest one. I think it's the first one.
This one?
I think so.
What? That's underlining.
Oh. No.
Oh wait, no. Sorry, I zoomed in because I'm about to write with my pen. So this is for underlining. This is a text. This is a text with a box.
Oh, never mind. I misunderstood what you're
asking. That's okay. That's okay. No, I'm zooming in because I'm about to do it. She said it's the 118 over the 8 what? 76, right? This gave us 0.1347. Right? Use proper notation. What is this thing? Isabella, you said it's a sample proportion. Your quizzes have been asking you about identify the symbols we use. Hold on. I feel like you guys are missing this part. Didn't we go back here? Oh, it's not here. Oh, it's over here. You guys see this, right? P, mu. Okay. It's on the screen. Do you guys not see all this?
Yeah, I just don't have it memorized sometimes.
But it's right there on
No,
screen.
but when you go back to the PDF, I don't have the whole thing in front of me.
No, hold on. Are you saying that I'm saying, do you know memorize P, memorize mu, and then memorize these things?
Yeah, kind of.
Hold on. But do you have these memorized? Everyone. Does everybody have this memorized? Okay, then if you haven't memorized, that means you're memorizing and not learning. Because if you do have it memorized, you don't know what it is. This is P hat, sample proportion. Isabella, isn't 118 out of 876 a sample proportion?
Yeah.
Okay, so what am I going to write here?
So it would be P. Something would be in parentheses, right?
Oh, that's it. Done.
Oh, that's it? Oh my God. Okay.
Okay. No, so it's not your fault. That's got to be on me when it's so simple, but I feel like I didn't explain it. I need to know what I didn't explain.
No, it's just, I mean, I what you said, like memorizing it, but not really like learning it.
Okay.
Yeah.
Yeah. You're not the only one. I mean, we have like 4 other people in the class, right? So that's what they mean by notation. P hat is this.
Okay.
Use the value found in part B and the confidence level given above to construct a confidence interval for the ease. Okay, so that's easy, right?
Mm-hmm.
We go to stack crunch. We pick our stack calculators, proportions, one sample with summary, 118 successes. So what we mean by success again is you have a little underling of a secretary and you tell him, go find me the proportion of e's in the English language. He goes to a book. He looks at the first letter and he has a little pen and paper and he's tallying. Is that an E? Yes or no? Check. Is that an E? Yes or no? That's an O. No check, right? And he does this 876 times through the paragraph. He successfully found 118 values that satisfy the requirement of being an E. Confidence interval. What do they want? I forgot already. 90? 99?
99.
Yeah. Okay. So 0.10499 to 0.644. Is there an interpret on this? There is. Okay, I was going to interpret it right now, but it's not. 99%. Being inconsistent and not using the same number of decimals in both answers. If I use 5, I'll use 5. Based on the interval found in part C, is it possible that Morse code's proportion is still true? Yes. Any questions? Okay. So, is it as odd, this worksheet now? Like, 'cause you got to connect all the previous information with the stat crunch, with the interpretation that we did yesterday.
Yeah, it makes sense now.
Okay, great. All right, so it's 9:06. I'll take one last question if you have it. Otherwise, I'm going to end the session now.
Real quick.
Uh-huh.
I'm okay, but thank you so much.
Okay.
Bye.
I just made the last one, sorry. Memphis,
So, since this is the first time, it's understandable, but make sure you're able to construct and synthesize these sentences, Samantha, so that the wording makes sense, so that you're able to create this on your written exam on Friday. Because, yeah, I mean, the sentences make sense as you read them, right?
Mm-hmm.
Okay, so.
No, because like I can read you what I wrote for my on the other worksheet, the homework assignment number 3, part D. It's just I know probably got it correct. I just worded it weird. So seeing that shows me how I can word it correctly. Like it was asking, is it less than 15%? And I said yes and no, because the proportion is between 1.91%, which is less than 15%, but the thing also goes to 15.87%, which is more than 15%, saying it is rare for it to be higher than 15.87, but you can still get 15.87.
Right.
Higher than 15. So
Okay.
I don't know if that made sense.
No, it did. So what if I were to read that, I would understand that the student gets to it, but doesn't grasp this concept that I hope you've learned in the last 2 hours, is that it could be any value in that interval, and we're confident that it could be any of these values up to a certain percentage of confidence. And so what we are saying is that we rule out the likelihood that it's outside of this interval. So if it's inside, the interval supports the idea. If the value is outside, then the interval doesn't support that idea.
I got you. So it's just a yes.
Yeah, like meaning, could it be 15%? It is, because 99% of the time that we sample, we would expect such a value to be within our window range. And that only 1% of our constructed intervals, 1% of proportion values would be outside of our interval.
Okay. See, that makes
because I'm on camera, I have to use correct wording. 1% of the samples would have constructed intervals that don't contain. Never mind. Just forget what I'm saying. I'm gonna have to work on this later. I have to actually maybe talk to a professor about the phrasing and the wording, because the reason I'm hesitating and stuttering so much for these sentences is using the word probability, because a proportion value does not move. It's not a moving target. It's stuck in one place, right? So I can't say the probability that it's in or the probability that's out. It has more to do about constructing intervals and collecting samples. And this one interval, right, we're saying compared to doing this multiple times, only 1% of them are going to not capture the population parameter. And because only 1% of them don't capture it, it's kind of like saying only 1%, there's only 1% of values that are not accounted for. Again, I tried doing it again, and I still stumbled and failed to write the good sentence.
No, but I get what you're saying.
Yeah. Okay.
I just kind of wanted a skeleton of it. Not that I'm like copying it, but I just want a skeleton so that I can change it for each like different thing, because that gives me an idea, if that makes sense.
Mm-hmm. And also notice, some of these I kind of changed the grammar, the proportion of E's used versus the use of the letter E versus consists of the letter E. You get what I mean? So you don't have to like be exact with the phrasing, but like I'm trying to practice using different phrases that mean the same thing. Okay. All right, so I am going to end it now. Thanks for stopping by.
Thank you.
Thank
Yep.
you.
Have a good night. Bye.
You too.